By the way, you have logged into your calculators if you haven't already. Let's take a look at what the first grouping here is going to look at. First one up, we need to figure out what the common ratio for this is going to be. When you see common ratio, what should you link to that? Hands up, please, if you can tell me. What have we talked about that we should be sort of linking to discussions about common ratio? We got 3 people. That's not good. Yeah, it's going to be a geometric sequence. So looking at this, what would we do, Haley, to figure out what our common ratio is going to be? Careful. I'm going to tack the whole thing on. A to the third, B to the fourth. Take that second term and divide it by the first. 1 over 64, A to the fifth, and B to the, what is the third? Okay. Now, just so you know, on the Regents exam, if it's asking you to find the common ratio, do you need to prove that it's geometric? You do not need to prove that. Why? Because it tells you, it's implied by the question itself. So, what we're going to do from here, and this is the part where I don't care, I want you to use the calculator if you need it. Do control division, put this fraction in the numerator and this one in the denominator. We need to divide these to determine what our common ratio is. So all of you right now are going to go in and take the fraction over the fraction. The calculator will do it. You just have to hit the buttons. And I'm going to ask, let us know what you get when you do that division, please. -6. Is that what we got? Okay. And that would be in the numerator, because -6 is a fraction, would be -6 over 1. Now I'm going to divide the A's and the B's. Michael, what's left and where when you divide the A's? Okay. Next part that we're going to look at, what happens, Taylor, when we divide the B's? What's left and where is it? There you go. Questions on that? Next one up, we need to solve algebraically. So, Chloe, what are you going to do to solve that one in the middle? Good. So what's that going to look like when you put it in exponential form? No? Now, you don't need a calculator to do this. You do not. Looking at what's there, we can use it to help us later, but to get you ready for next year. Maddie, what does this exponent mean? What's the numerator represent and what's the denominator? Perfect. Which one do you want to do if I take the calculator away from you? Do you want to take 27 raised to the 4th power, or do you want to take 27 and take the 3rd root of it? What's the cube root of 27 going to be? 3. Now, on that, we need to take 3 to the 4th power. So, hands up, please, when you can tell me, without the calculator, 3 to the 4th power is going to be 81. So, with that in mind, I will go through at this point and say 81 is equal to 2x minus 1. From here, I'd add the 1 and divide by 2. So, 82 is equal to 2x and divide both sides by 2. So, x is equal to 41. Now, why is it absolutely and unequivocally unacceptable for you not to get this question right? And we're talking everyone getting it right. What? Go in right now, please, and use NSolve to check that out. Sign in if you haven't already. Try the NSolve with the original. By the way, we'll do this one out. Press enter. Try the NSolve, though, with the original, because we could have put it in the wrong form, and we would and we would be stating the answer to something that we incorrectly went through and did. So do log base. What's the base? 27, 2x minus 1 equals 4/3. You're going to get from me on the Regents exam. How about you? Are you going to actually work for it, or are you going to complain your way there? There you go. Now, we did this one right. Here's our next one. We need to solve this algebraically. So, Jonathan, what's your first step going to be?
That you have to get 15 on the other side.
Okay, so we've got x to the 4th plus 4x to the 3rd plus 4x squared plus 16x is equal to 0. How many answers is this going to have, Peter? What are you going to do to start this off? So what's left when you take the x out? Now, we're not done yet. What's next from here? Allison? So what can you factor out from the first two? Now, that still has more work to be done. We did an initial GCF. What can we still do on what's there? Hands up when you can answer that. Go ahead. Yeah, a GCF again, because what do the left and right halves of this both share? What do the left and right halves share? An x plus 4. So we've got an x. Now when I take out the x plus 4, what remains? Okay, and this factor further. Alyssa? So what? No. Does it factor further? What's the temptation to factor on this? Hands up if you can answer that. What's your temptation? And you're going to fight the urge. You are going to fight the urge, Haley. What is it? And what is close to that does factor down? What would it look like? There you go. Do you judge people who try to factor x squared plus 4? I would. I wouldn't let them sit near me. You'd be nervous it would rub off on you. So we're going to set all of our factors to be equal to 0. Johannes, which one do you want to go through and solve? I know you can't do the x equals 0. Okay, what are you going to do with that? And then do what? And what are you going to give as your answer? If you do that on a kid, you don't get me 100 because of that. And how angry I'll be? Yeah. What do you leave it as? Okay. We'll have class out in the rain if we start making those mistakes. I will punish you severely, all of you. Wouldn't that be wonderful if we had class outside today? No one asks for class outside on days like this. I always wonder why. It's warm. Can we go outside? No. Now, how many people haven't logged in yet? Good. Now, have your notes out and answer the question on your calculator, please. There's 20 of us today. Let's all get our answers in. I've got 18 so far, 19. so close. You've got one holdout. Oh, is he? Let's see. He is? Okay, sorry. So we're going to have 19 then for our numbers today. Looking at our values, which one is it? Look at this. Wow. Oh, blue. All right. Now, looking at these results, we're going to answer some questions. Take a look at the first one. Out of our class, what's the probability that a person's favorite color is blue? Hands up. Oh, we don't need this. Hands up, please, when you can answer the first question on there. Seriously? 3 people? Good. Questions do get substantially tougher. Emily, what would you say? Out of our class, what's the probability that a female is selected? Now, you all are going to look around the room right now and take a quick inventory. Don't forget to count yourself. Hands up, please, when you can answer that question. Wave to each other. Some of you are seeing each other for the first time, it looks like. Hands up, please, when you can answer this question. It's a little startling that it's taking this long. All right, so who's got an answer? Chloe, what do you say? 11 out of 19, all right. Now, let's narrow it down. If the person chosen is female, what's the probability that her favorite color is blue? So, how can we figure that out? Well, who are my blue people? Hands up. There's supposed to be 12 of you. Okay. Now, I need you to, nice and high, we're not doing the deodorant check. That means this, not this. Get up here. Reach for the stars. Now let's answer that question. So you're going to have to keep your hands up so we can get an answer to that question. Hands up, please, when you... Oh, you already got your hands up. Looking at what's there. All right, you can put your hands down now. Who can tell me the answer to our C question, which was, if a person is female, what's the probability that her favorite color is going to be blue? We got an answer for that. Go ahead. 6 out of 11. Out of the people whose favorite color is blue, what's the probability that the person is going to be female? We got 3. 1/2. Why do you say that? Because there are 6, or out of the people whose favorite color is blue, probably their females. There's 12 total blue people, and 6 out of those 12 blue people are girls. Now, the stuff we're going through and doing today, and I have to go, well, I'll caution you this. This is our first year of going through and doing the probability. So, I'm not as, like, pretty much everything I'm 120% right on, and I can do it with my eyes closed. These are ones where I have to go through and do the notes the night before. So don't complain about your homework, because I still have homework too. Not only do I have to talk about all these stupid questions, I have to go through and actually do them out so I know what I'm doing and don't look like a doofus in front of you all. Because for me, it's not always the easiest thing because there's a ton of reading. So, taking a look at what's there, we're going to talk about conditional probability. And conditional probability is the probability of an event occurring given that something else has already occurred. So, what we just talked about was an example of conditional probability. If A, then B. And one of the things, I think it actually comes up in computer science. And aren't there conditions like if this, do this? Is that right? So if you take comp sci, that's one of the reasons that, frankly, you all should be taking it for the 800th reason. But if something happens, do this. And it's a bunch of conditions to go through and be met. So as you're doing this, the notation of it goes P bar A. But it's saying the probability of B given A. And the definition of that probability formula looks like this. Probability of B and A all over the and that's what this notation means, by the way. P parentheses is P like the probability, so like the probability of a Wednesday or something like that. So for what we just did earlier, probability of blue given female, the way that you can compute that is you would have to take the probability of female and blue over the probability of female. And that's where those come from. Questions on that? All right. Next one up. Look at that table there. Look at all of the stuff that we're talking about. Samples were taken about people's favorite movies. We need to find these different probabilities. Go through right now and try to figure out A, based off of what we did, and especially what that formula is. Try to figure out A. And set up the actual probability that will help inform what you're going through and doing. And Emma K, what is the setup of this going to look like? Hang on. You look at the numerator. Like if you were to fill into the formula, it's the probability of liking a comedy and then meeting those conditions. So what would the numerator of this look like if you were to fill this in? It's the probability. The numerator is going to come from what? The probability of what and what? Yeah. So it's got to be comedy and that age range, 26 through 49, and you're going to divide that by what? The probability of the age group, which in this case is 26 over 49. So now let's look at what we have. How many like comedy and are 26 to 49? What's that going to be? It's going to be 472 over what? What would our denominator be, Peter? 1,000. Yeah. You can reduce that on your own. Questions on that? The setup on them is the toughest part. Take a look at the next one. What do we need to go through and write out for the next one before we plug numbers in? Noah, what would you say?
You need the probability of horror and 50 plus.
So 50 plus and horror all over what?
The probability.
Yep. So looking at that, what would our numerator on this be? We need to take the probability. Well, you tell me. What's our numerator on this going to be? Tyler?
190.
And it's going to be over what?
1,000.
No. 680, yeah. because you're comparing it to the whole. Remember, it goes as we're working across the probability of B given A. So what this is telling us is the probability of them liking horror given that they're 50 years and above. This next one is the probability of being 50 and over given that you like horror. It doesn't seem like a big difference, but it kind of is going to be. Alexa, what's the numerator on this going to look like? What's that? What's it going to look like? Sorry, it comes from what? The probability of what?
Probability for
Yeah, being over 50. So your numerator would be how much? 190 over what? There you go. That's 1,000. Company sells a product designed for young adults, and they want to advertise. You tell me which one should they go through and pick. They're going after young people. This is what our market research is. You tell me, what do they want to go through and pick? Jonathan? Why?
The most likely to be watched by that age group.
Mm-hmm. If the company wants to advertise to older adults, which one are they going to go through and use? Yeah. I'd agree. Yeah. Oh, least beneficial. I'm sorry. Which one would be the least beneficial then? Sorry. Questions on that one? All right. Let's go and look at question number 3. Go through right now and answer A and B. Sarah, did you get an answer for A?
Yeah.
How did you get, what did you write out? Let's start off.
It would be probability of acne cream and improvement.
Make sure you got it in that right order too. They're using the cream and that they're having improvement. So what's the numerator going to look like? It's going to be the P, I, and C all over what? Yeah, so what's your numerator? Oh, sorry, what is the numerator that's going to be? I'm sorry.
800.
Over.
1100.
There you go. What about for the second one? Jack, what's your setup on that going to look like? What given what? So probability of no improvement given what? That's probably no improvement given that they did what? That they used the cream. So probably with no improvement given that they use the cream. So that's what the setup needs to be. If you are not writing that down, you write the whole thing down. Now, what is this going to look like, Jack? How would we compute it out? Oh, well, hang on. I have this. I'm sorry. Was that what you were going to say, Johannes? I have it backwards. Why? Was I saying it right or no? I don't know if I was even saying it right. Yeah, I have these in the wrong positions. It's going to be, because when we were going through and saying, out of the people who saw no improvement in the skin, what's the probability they went through and used the cream? So it should be the probability that they had used the cream, given that there was no improvement. I don't think it's going to impact the final answer. It's just going to impact what our denominator is going to be. Well, it'll impact the answer because of the denominator. So, looking at this, what would the numerator look like, Jack? You need to find the, and again, this, if you're not putting this down, the next step, it's not magically that random numbers start showing up. You have to show me where they're coming from. That's the justifying your answer. So this is the probability that they used cream and that they had no improvement. And how many of those did we have, Jack? And what's your denominator going to be? What do you have to look at in the denominator? Same as all the other ones. You can tell me what needs to be in our denominator. Probability of what? Yeah. No improvement. So, Jack, how many of them had no improvement? No. I get 1100. Sorry, why did I get 5?
300 to 200.
Oh, this way. Sorry. Yeah, I was wondering why I had. Sorry. How many had no improvement? 500. These are called two-way tables because you got to go left, right, up, down to get your total. Jason?
What is, like, when you say P of something and then that line, something is
Probability of B given A. So you're saying, what's the probability that this happens if this is already happening? Okay? So and that should already be written out for you on the last one. Now, take a look. What we got over here. What's the probability that the person used the placebo and that their skin improved? So look at what's there. You tell me what's the probability that the person used the placebo and that their skin improved. How many people used the placebo and had their skin improved? What? 600 over. How many total are we looking at? What's that? Not 1,400. How many? No. How many total people? 1,900. How did you get that? That's your total. Look at the add all those numbers up. How many total people are looking? Yeah. Hang on, please. I can't hear you. What? No. What's the probability that the person used the placebo and that their skin improved? And. So it's an and question. It's not, it doesn't need this conditional probability. What's the probability that both of those events happen? So, how many had both of these events happen? Well, the probability that the person used the placebo and that their skin improved is this right here, the 600. The probability, the number of that have it. To figure the probability, you divide by the whole amount, and the total number of people in this trial would be how many? 1,900, yeah. What's the probability that a person who used a placebo saw saw improvement in their skin. So that's going to be one when you're setting this up. Is this a conditional, yes or no? Yeah, because we're not looking at the whole group, are we? We're looking at the probability that they had used a placebo and saw an improvement. So the probability of improvement given placebo. Not given the whole group, improvement given placebo. So looking at this, I would go through and say my numerator is going to be the number of improved and placebos that we had all over probability of the placebo. What would we go through and get for this? Hands up, please, when you can tell me what your answer is going to be. Great. If this, then this is going to be the time when we need the bar. Let's go over, please. How many more do we have? Just double check. Tree diagrams. Okay. Let's actually do this. Tables. I don't think we have enough time to go through and do all of this. Let's do this. I'm going to leave two-way tables, and we're going to come back to it. So we're going to pause, put a star or something on page 18, because we're going to come back to it. Just because I don't think we'll be able to finish it in time, but there's something we can bang out that hopefully will be kind of quick for us to do, which is, let's go over to where it says day 4 stuff, where you've got to do tree diagrams and conditional probabilities. Have you done tree diagrams before, yes or no? Okay, something like it. That's why I think we can get through that within the 15, 20 minutes that we've got. Take a look at that first one. Draw a tree diagram that represents all possible outcomes visually and assigns probabilities to the events. So the first thing I need you to do is draw a tree diagram that represents a coin being tossed twice, and then we need to go through and figure out what the individual probabilities themselves are, and we'll answer the second half. But draw a tree diagram for a coin being tossed twice. Go through and do that right now. Haley, how many choices are you making? How many branches are you going to have from the first flip? 2. You've got 2 options, and what are those 2 options, Haley? There's a heads and a tails. If I get heads the first time, I still flip the coin. What's the probability, or what are the outcomes? How many outcomes could I have, or branches off of the heads are there going to be? 2. What are they? Same thing is going to happen down here. So looking at this, what's the probability of getting heads? Hands up, please, if you can answer that. And what's the probability of getting tails? So each of them has an equal probability. What's the probability of getting heads given heads? Well, this would be a half here again. So the probability of heads given heads would be 1/4. What's the probability of tails given heads? forth again. Each of these outcomes is equally likely to occur. Now, we need to find the probability of first loss heads and second toss heads. So I'm going to ask, what is that probability going to be? Yeah. You can also go through and put conditional probabilities on this. So this would be the probability of, do it this way. So if this is our first choice here, heads, tails. I said before this was heads, tails, heads, tails. In terms of conditional probabilities, this would be the probability of heads given heads. You could also go through and say that this is the probability of getting what given what? Tails given heads. The first condition that's met goes second. The next one up is the probability of probability of heads given tails. So this would be the probability of heads given tails. And this one would be the probability of getting tails given tails. Questions on that one? Now, this next one is going to be a little bit more complicated. I can give you a ton of space to go through and draw this out. I might give myself more. Looking at what you all have, it's got a bunch of conditions that needs to be met. An auto company charges younger drivers higher premium than it does older because younger drivers tend to drive or have more accidents. They've got 3 age groups. Group A is under 25 and is 22% of policyholders. Group B is that age range and that percentage, and everything else is 40 and above. Company shows that given any 1 year period, 11% of its policy A holders have accidents. Percentages for B and C are 3 and 2%. Now, we're going to draw a tree diagram to represent this situation. I'm going to make it a lot bigger than you all can make it on your paper. How many choices are there for or how many branches are we going to have, I guess, for our initial decision or our initial choice? Hands up, please, if you can tell me that. Jason? 3. So to start with, I go through and say, and from those 3 branches, I'd say I've got 3 groups. One group is going to be Group A, one is Group B, and one is going to be Group C. One's A, one's B, and one is C. Looking at what's there, the next thing I go through and do is start putting some probabilities on them. What's the probability that the person is in Group A? Hands up, please, if you can tell me. So I'm going to label that probability 0.22. What's the probability that the person is in Group B? Yeah. 0.43. And then the probability that the person is in Group C. Michael? 0.35. It didn't give you that, right? You had to subtract to get it. Is that correct? Okay. Now, if you're in Group A, how many branches are you going to have coming off of A? Hands up, please, if you can tell me. Yep. What are those branches going to get labeled? And that's going to be the same for all of them. You're going to have an accident and a no accident group. Now, what's the probability of an accident given Group A? Hands up, please, if you can tell me that. What's the probability of an accident given Group A? We got 1, 2 of us. So, yeah, 0.11. What's the probability then of no accident for Group A? Peter? Yeah. 0.89. What's the probability of an accident for group B? We got one person. Probably an accident. Michael? What's the probability of no accident then, Taylor? Next one up, what's the probability of an accident in group C, Chloe? So we drew the tree diagram. The next one up, it says, and we're going to use this to inform, I'll be bouncing back and forth. What percent of the company's policyholders are expected to have an accident during the next 12 months? Well, what percent of the policyholders are going to have an accident? How can we figure that out? We have to go through and, well, what do you want to say? How would you do it? Yeah. Perfect. That's exactly it. To figure out what's the probability or the likelihood that you're in group A and you have an accident, how do you figure that out? Multiply them together. Probability of group B and an accident and probability in group C and an accident. So go through and do that right now and make sure you actually show out the work where the answer comes from. So we drew our tree diagram. You can tell me what numeric answer we got for this. Jason?
0.0441 or 4.41%.
0441. That is correct. I like to stick with the decimal. Oh, it says percent? Sorry. Which converts to, as Jason told us, 4.41. Next one up. Find the probability that they had an accident given that they were under 25. So, how would we figure that out? Well, we've got to figure out the probability that they are in which grouping? A, and that there was an accident. From what I understand this, I actually think this is correct data too. Looking at this, how would you figure out the numerator? Well, you need to figure out the probability that the person had an accident given that they're in group A. So looking at this, probability of and being in A and having an accident over the probability overall that the person had an accident. Looking at what's there, what's the numerator going to be in this case? Hands up, please, if you can tell me. What do you get when you compute it out, Emma?
0.242.
You said 0.0 what? 0.0242. And you're going to divide that by what?
0.0441.
So what is the likelihood of that? Do you want it as a percent or no? No? Is it 0.55, is that right? Yes or no? Okay. Sure, if you want to. I just hate percents. Doesn't matter though. Okay. So as you do these out, you've got to give yourself some probability. I think we can bang out these next ones. A jar contains 3 flavors of jelly beans. Accordingly, someone takes one out. We need to draw a tree diagram to represent this situation. This one's actually going to be slightly awkward. We're going to label the probabilities as well. How many choices or how many branches am I going to have, Maddie, coming off of the first decision? 3. And those choices are lemon, watermelon, and raspberry. And now, once I make that initial choice, how many branches are coming off of each of those? 3. So, and it would be lemon, watermelon, and raspberry on each one. Draw a tree diagram to represent this situation. Let's label our probabilities on here too. What's the probability of getting a lemon? Hands up if you can answer that. Probability of getting a lemon. What would that be, Jonathan? Yeah, 16 over 36. Probability of watermelon is 12 over 36. And the probability of raspberry is 8 over 36. Now this is where it's going to get awkward. What's the probability of getting a lemon after you already got a lemon? It's probably getting a lemon after you already got one. Peter? 35, yeah, so this would be 15 over 35. Probability of getting a lemon given, or sorry, getting a watermelon given a lemon, so this would stay the same at 12 over 35. The next one, raspberry, would be 8 over 35. Now go through and fill in the remainder. For B, we have to go through. For B, we have to go through and get the probability that this person gets 2 lemons. So that would be, I guess there's more than one way of saying it, but I view it as lemon and lemon. What's the probability of, how would we get that answer? You tell me. How would we compute lemon and lemon or lemon then lemon? What would we have to do? One person. Michael, what do you want to try?
Multiply the probability of drawing lemon jelly beans first times.
Which is?
16 over 36.
And you said times what?
Probability of drawing another lemon jelly bean.
Which is?
16 over 45.
What value is that going to come out to be? Hands up when you can tell me. What value do we get, Jonathan? Is that it? Is there more after that, or is that rounded or final? Rounded? Okay, then don't give the rounded. Give the actual one. Who can tell me what this will come out to be? I think that the fraction, from my answer, if I remember, I put down the fraction because the decimal's awkward. Yeah. Yeah, 4 over 21. You're allowed to use whichever one you want, unless it specifically says, like the one before, that you have to go through and use percents. What's the probability that he's going to eat a watermelon and a raspberry in either order? Well, we've got to take 2 situations into account. We have to take the probability of watermelon and raspberry, and then raspberry and watermelon. McEntee? Yes. Yep. Thanks. Jack down to Mr. Lambert at the end. So first thing up is I need to compute the probability of watermelon and raspberry. And to that, I need to then add the probability of raspberry and watermelon. What's the probability of watermelon and raspberry going to be? Hands up, please, if you can tell me how we would compute this one out. Yeah. 12 over 36 times
8 over 10.
and then we need a raspberry, then a watermelon. So that would be, what? Peter? No? How many watermelons are there? 12 over 35. Who got an answer for that? What's the numeric value of that going to be? You can give it as a fraction. I think the fraction's easier. We got no takers? Jonathan? Yeah. So let's table where we are right now. And we'll come back, and I wanted to get this done because I thought we could get further in it than others. One thing before you all go today, maybe there's two things actually. Okay, before you go, there's more papers back here. Nothing from Jensen. All of it? No, okay. Find me next time. There's just a couple papers to go through and hand back. I do though want you to do this. I'll give this to you. Starter. Before we start with the obligatory, when is the test on this? When is the test on this? When is it? That's not how we roll. You need to know how to do everything. The test would cover anything. I'll give you this to go through and do. Now, Ms. Bailey collects them and grades them from them. The problem, I'm not going to ask you. I probably wouldn't collect it, at least for a substantial grade from you. You'll pick it up on Jack's desk when you leave. Because they copy, like, you all just become human Xerox machines. So, I'll tell you this. Know how to answer all of those questions by, and you can change the date to next Friday. We'll give you a week. Know how to answer all of those questions. Have a great